In the last section of Chapter 5, 5.6, we're going to talk about the fundamental theorem of algebra. The essential understanding of this section is that the degree of a polynomial equation can tell you how many roots that equation will have. So for example, let's just look at quadratics. A quadratic means you have a degree of 2, so you see an x squared somewhere in that equation, or that's your highest degree. When we did quadratics back in Chapter 4, we found that you can either have two real zeros, so here we have f of x equals x squared minus 4. We cross the x-axis twice. You can also have one real zero, so we're like just touching that x-axis once. Or you could have situations where you have no real zeros. But if we look a little bit deeper in this, x squared minus 4 breaks down to x plus 2, x minus 2. We have two real roots at negative 2 and 2. You can easily see that when graphing it, you see you cross the x-axis at those 2 points. For x squared minus 2x plus 1, or where you had one real zero, we can break this down into factored form as x minus 1, x minus 1. And simplifying that even further, we could write that as x minus 1 to the second power. So, remembering what we talked about with multiplicity, that means that we have one root at x equals 1 of multiplicity 2. Finally, our equation that never crossed the x-axis, x squared plus 2x plus 2, we could also find we kind of hit a dead end because if we try to factor that, we couldn't. If we broke this down using the quadratic formula, like so, and then simplified it, and then simplified it again, and then simplified it again, I find that I have roots at negative 1 plus or minus I, which those are also conjugate pairs of each other. So overall, even though I don't cross the x-axis at all and I don't have two real zeros, I find that I have two complex roots at negative 1 plus I and negative 1 minus I. The overarching theme here is that a quadratic of degree 2, no matter like what kind of equation you have or what it looks like, you either have two real roots, a root of multiplicity 2, or two complex roots, which leads us into the overall theme of the fundamental theorem of algebra. The fundamental theorem of algebra states that if p of x is a polynomial of degree n greater than or equal to 1, then p of x set at equal to 0 has exactly n roots, including multiple and complex roots. So for example, if you had a polynomial that went to degree 11, combining real roots, imaginary roots, or a root that has like a multiplicity of something, all of those added together should equal 11. So if you have a degree of 3, you should have 3 roots. If you have a degree of 4, you should have 4 roots, so on and so forth.